Welcome back, team, to another video. In this video, we're going to be going over the activity 6 for the defense and discussing how do you find a solution for that? How do you organize your answers, and what does it look like to use the different probability rules that we have in order for us to get a solution? So in this problem, you have a student named Mari, and Mari really wants to be a defense attorney. So in the court system, there's the prosecution and there's the defense. And so she wants to be part of the defense, kind of like a lawyer, but defending people. She's very excited because her civics teacher has announced that the class will soon begin a 4-day unit on the court system. The class will act out a different famous court case for each day. And at the beginning of each class, the teacher will use a die to decide a student's role. If the die comes up a 6, the student will be a defense attorney. If the die comes up 1 through 5, the student will play some other role. So first and foremost, a die. A lot of students, you read it, you read this word, and you tend to forget that it's just a die. Most of the time, you play with 2 dice, and you play Yahtzee with them. You play Monopoly. It's just a couple die. And so for this problem, the teacher actually is going to roll a die and decide where the student is going to be placed that day. So in this problem, to set it up a little bit, what I like to do is I like to first draw out kind of what the situation looks like. So we know for sure that there are 4 days. So I'm going to call this day 1. Call this day 2, day 3, and day 4. This isn't something you necessarily have to do, but for me, I don't want to know kind of how many different events may occur during a situation that may help me solve the problem. So in this case, there's 4 different, I'm going to call them events. In this case, they're different court cases. And each day, Mari has an opportunity to be the defense. So she could technically be the defense here, or she could be the defense here, or both days, and then she cannot be the defense there. We don't know what's going to happen yet. So it's our job to calculate that probability. All right, so question number 1 really wanted us to either do a tree diagram or an area model to to set up how likely she will be a defense attorney over the course of the 4 days. So when you make a tree diagram or area model, the key thing that I want you to understand is this is simply just making a diagram or model of the situation. We don't need to calculate anything for this so far. It's just creating a diagram or model. So in this case, we're going to have 4 different days and 4 different possibilities. So let's start with making a tree diagram and see what that looks like. So I like to start my tree diagrams from a point. Right, nothing's happened yet, but the first day, Mari has 2 different possibilities. She's either going to be part of the defense, which I'm going to call just the letter D, or down here, not defense, which I'll call ND. The first branches that come off of your main trunk of the tree diagram are going to represent your first possible event. So in this case, everything here represents my possibilities for day 1. In a tree diagram, though, if I go up the tree through this branch and Mari was actually defense on day 1, the next day, theoretically, she has 2 different options again. She can either be part of the defense or not the defense. Similarly, if she wasn't the defense on the first day, she can continue this tree and have different options for the possible second day. So all of this represents the second day. We can keep this tree diagram going. We have the defense, not defense, defense, not defense, defense, not defense, and then ultimately another defense and not defense. Now, this is the part where students start to get a little bit confused because they say to themselves and they say to me, Hernandez, Mari can't be all of these things at the same time. She can't. How is there 4 different opportunities for her to be defense? Well, it's all dependent on which route of the tree you take. So if she started off by not being a defense, then she can go to be a defense and then back down to not being a defense. So she can follow this route of the tree in order for her to achieve her goal of being the defense for certain days, but then not for others. Similarly, she can also do the thing where she goes and she becomes a defense for the first day, but then she's never the defense again. So that she would follow a different branch of the tree. For tree diagrams, you can only take one branch. Only one branch of events can happen at a time. So I'm going to put a little note here. For a tree diagram, only one, I call them branches, only one branch can happen at a time. You can't go through a couple different branches. You can't be the defense and not the defense. So you can't follow 2 different routes at the same time. Okay. So this is 3 days. Let's go ahead and finish our diagram. She can be the defense for the last day or not defense. Defense, not defense. Defense, not defense. And this is where I start to get a little tricky because I really want to make sure that my branches are as straight as possible, but I didn't give myself enough room. So making tree diagrams, this is the worst part of making tree diagrams, is you start running out of room. So I hope that your diagrams, you start finding the space so that way you can make them big enough. Oh, not defense. Okay, so this represents day 4. And ultimately, whatever your last event is, so in this case, day 4, this would be how many different, you could say, branches that we can take, kind of, right? So you should be able to reach any of these options, any of these possible events by going through a branch here. There should be nothing listed in your tree diagram that can't be reached, right? So there isn't just randomly like one route out here that says, oh, she could be the defense. It's all has to be connected somehow because each day has to be, they have to depend on each other to some extent. Okay. Now, this is a tree diagram. And typically what you would do with your tree diagram is then list out the possibility or the probability of having each of these for each individual day. So in the tree diagram, what you can write afterwards is the probability of Mari becoming a defense attorney, according to the problem above, is a 1 out of 6 chance by rolling a die. And the probability of not getting a defense is going to be the rest of the options that are listed on the die. So everywhere where you see a D for defense, this corresponds to having a 1 out of 6 chance. Technically, you can go ahead and replace everywhere where you see the letter D with a 1 over 6 and ND with 5 over 6, but then your whole tree diagram would be filled with numbers, and that may be confusing later. So this is what I like to do with my tree diagrams, so that way I can see all my possibilities and then the corresponding probabilities for each. Okay. Moving forward, it also wanted us to do an area model. An area model is a little bit different because we have to take into account each day that you have and make an area model to represent all of the possible probabilities. An area model for this situation may be a little bit confusing to create, so I'll show you like the starting steps, but we're really just going to use the tree diagram for today. So if I come over here and I set up my box for the area model, we're going to start off just by looking at the first day and what can happen. According to the first day, I need to roll a 1 out of 6 in order for me to become a defense attorney. So I would put a line down here, and I'm a person who likes everything to be exact. So this is exactly one column out of 1, 2, 3, 4, 5, 6 possible columns. So here's the opportunity. Mari can either be the defense, or in this area, it's considered not the defense. And then you can have a day 2, and there's actually a couple things that can happen. I'm going to go this way now, and there's an opportunity here where Mari actually can be the defense for both days. So I'm going to say 2 defenses, or she could be the defense for day 2. So I'm going to put D2, or she could be the defense just for day 1. Or in ultimate, there's just no defense on both days, which has a bigger chance of happening. So in this case, this column here would represent the defense for day 1, and this big old column over here would represent not defense. Over here you get defense for day 2, and over here you'd get not defense. It's really easy to make an area model when you only have 2 different events occurring. Now, if we were to add day 3 in here, theoretically, day 3, this is where it gets confusing for students. Because if Mari was the defense for both of the first 2 days, there's actually a possibility that Mari could get the defense for all 3 days, or she can get the defense for day 1 and day 2, or she can get the defense for day 2 and day 1, or she can get the defense for day 1 and 3, or day 1 and 2. And so it starts becoming really confusing because then now there's a bunch of different other possibilities that enter here. We still have the big chunk that says she's not going to be the defense, but now we have to take into account a third possible outcome that's going to enter our area model, and it gets pretty confusing to do. So let's stick with the area model when we have 2 events. That'll make it easier. We'll discuss how you can kind of segment this later on, but we'll talk about that when we get there. Okay. So we're going to use the tree diagram to help us solve this problem. In this problem, we want to answer the question, the primary question. I'm going to do them over here so that way we can see our tree diagram a little bit. The big question that they want us to ask is in number 2, which is what is the probability that Mari will be the defense for every day? In other words, this is asking what is the probability that Mari will be the defense for 4 days? Now, let's use our tree diagram to help us answer this question. If I zoom in a little bit, remember, we only have 4 days of this unit for civics. So Mari wants to be the defense, be the defense, be the defense, and be the defense. So we need to look at which branch of our tree diagram actually has us being the defense every day. So if she starts off day 1 being the defense, she needs to then be the defense every single day. So she's the defense on the first day, defense on the second day, defense on the third day, and defense on the 4th day. So we'll be taking this upper branch of our tree diagram and calculating the probability for that. Now, luckily, every time we follow a branch of the tree and we only follow that one branch, all of these events are in order such that we want the defense to happen and defense to happen, and defense to happen, and the defense to happen. So each branch we want to happen. So each branch we're going to be using and, which means we're going to be multiplying probabilities. If we're comparing two different branches, so I'm going to put it down here, comparing two branches, two or more branches, we add because we want this branch or this branch to happen, but both of them can't happen at the same time. In our case, using one branch, we multiply probabilities. And this one we add probabilities. Okay, so let's go ahead and look at this. And what I'm going to do is I'm actually going to lasso this if I can, because I don't want this to go away, but I want our branches to go off because I want us to look at another example in just a second. So I'm going to go ahead and do that. And I'm going to undo every piece of this. And I'm going to make sure that we are all able to see the next problem using this same tree diagram. Okay. So right now we're going to be looking at this branch. We're going to be multiplying probabilities and looking at what's going to happen with Mari being a defense attorney every single day. So we're going to have the probability that she is defense and probability that she is defense and the probability that she is defense and the probability that she is defense. We want it all 4 days. So each one of these is going to represent a day. And in the problem, it says she has a 1 out of 6 chance. Each and every day. So in this case, what we're going to do is we're actually going to multiply these probabilities together. So we multiply the tops of each fraction. We get 1 times 1 times 1 times 1, which is 1. And then we multiply the bottoms together. And we're going to get 6 times 6, which is 36, times 6 is 216, times 6 again is 1,296. So the probability of Mari getting the defense for 4 days is going to equal 1 out of this amount, 1,296. Now you may be saying to yourself, Hernandez, that seems a little excessive, don't you think? Don't you think that's like a very rare thing to happen? Well, if you're rolling a die and you needed to come up with a 1 out of 6 every single time, yeah, it's going to be a pretty big number. So we want to make sure that we keep that in mind as we move forward, because if that's going to be rare for her to get all 4 days as the defense attorney, let's see what happens when we push forward and we look at something else. Okay. So number 3 says, what is the probability that Mari will never be a defense attorney? So we want the probability that she is not going to be defense for 4 days. Which, if you think about it, if we use our model from above, it's going to be the probability that she is not the defense, so the complement of the defense, all 4 days. And if you remember from before, I actually set up our probability looking at specifically this, but instead I noted it as the probability of us not getting the defense. So all of these ways are the exact same of looking at the situation. It's just kind of different notation that means the same thing. And so in this case, if we go back to our tree diagram and we zoom in a little bit, instead of taking this top route, looking at all the days of being a defense, we're taking the bottom route. No defense, no defense, no defense, no defense. Okay. When we go to calculate this, if we use the probability of Mari not becoming a defense attorney, that's going to be 5/6, because it's everything else that's available on the die, and we want them all to be true. And from multiplying earlier, we know that the denominator is 1,296. And now we need to multiply the tops together. 5 times 5 is 25. 25 times 5 is 125. 125 times 5. Oops. I'm doing this on my separate calculator. $625. So we have 625 out of 1,296, which the probability for not getting the defense for 4 days, we rewrite our answer is 625 over 1,296. And then this would be the answer that I'm looking for. So far, we've been using the product rule. We've just been multiplying because we want all the events to happen in sequence. We want them all to be true. We're looking at just one branch at a time. But now, number 4, we're going to be coming into another type of problem that we need to think about. On the 3rd day of the unit, the class is going to act out a case which Mari really wants to do. She wants to be part of that role. So Mari wants day 3 as defense, and then not defense every other day. So if we go back to our tree diagram, she wants the defense. Let me erase this really quick. She wants the defense specifically on the 3rd day. So the 3rd day, she wants to be defense, and then she does not want to be defense every other day. So she doesn't want to be the defense on the 1st day. She doesn't want to be the defense on the 2nd day. She does want to be the defense on the 3rd day, but then she wants to finish off by not being the defense on the last day. So you see, we take a specific route, in this case of the tree diagram, in order to make Mari's wish true. So in this problem, another way to look at this is if you list out each day. So day 1, not defense. Day 2, not defense. Day 3, that's when she wants to be the defense. And then day 4, not defense. So if we do this, we're actually looking at the probability of her not getting defense and the probability of her not getting defense and the probability of her becoming a defense and the probability of her not becoming a defense for the last one. If we plug in some numbers here, we end up with 5/6 because she doesn't want to be the defense, with a 1 out of 6 chance that she is a defense, and then finishing off with another 5 out of 6. Because we're multiplying, we already know the denominator, 1,296. And now we get 5 times 5 is 25, times 1 is still 25, times 5 is 125. And I'm looking for you to write your real answer. The probability of Mari getting day 3 defense, and then other for the rest is going to be 125 over 1,296. Okay. Once again, product rule. looking at the specific tree route. Okay. The last problem, the final problem. Sorry, the video is running longer than expected, but the final problem, problem number 5. We want Mari to be exactly the defense attorney one day, exactly one day. So the probability that Mari will be defense exactly one day. Now, some of us may immediately think, oh, that's 1 out of 6, right, Hernandez? Well, not quite. So I'm going to do 2 different things here. First, I'm going to list out my days like I did before. And then I'm going to go to my tree diagram, and I'm going to kind of check this out. So she only wants to be defense for exactly one day. So if we go back to our tree diagram, and we look, she only wants to be the defense for one day. So we need to keep into account exactly her wishes. So that means that she could take this tree branch, be the defense on the first day, and then never be the defense again. She can also not be the defense to start off, be the defense the second day, but then never again, because that's exactly once as well. She can take this bottom route again, not defense, and then become the defense on the third day. That's okay. Or she can continue down this route, not defense, not defense, and then be the defense on the last day. So there's 4 different possibilities of Mari becoming a defense. She can either become the defense the first day, the second day, the third day, or the fourth day. But she can't be the defense every single day because the problem only wants it exactly once. So if we're comparing branches, we're looking at OR, which is the additive rule. They can't all exist at the same time. However, we can add together those probabilities in order for us to get a proper fraction and a proper probability looking at exactly one day. So what I like to do is I like to look at that, and then I like to list out all of those possibilities. So she could be the defense on the first day, not the defense, not the defense, not the defense. She could not be the defense for the rest of the other options, and then become the defense attorney. She can be the defense attorney on the third day, or she can be the defense attorney on the fourth day. So in each case, there's only one option for her to be the defense, given each of the circumstances for exactly one day. So in order to solve this problem, we have to take a look. Each one of these rows is a different, I'm going to call them branch, so that way we can refer to them a little bit easier. It's another branch on the tree diagram. So this is branch 1. This is branch 2. This is branch 3. And this is branch 4. So for each of these branches, all of these probabilities can actually happen, right? So we're going to multiply them together. However, when we're looking between the branches, whatever those equal, we're going to be adding them together because not all of them can happen at the same time. So this is a little bit of a longer problem. So let's set it up. If I'm looking specifically at branch 1, I'm going to call it over here branch 1. We get her being a defense 1 out of 6, with the rest of them being not a defense. And we already calculated this the first time. It's 125 out of 1,296. Now here's an interesting thing, because for branch 2, we're using the exact same numbers for the fractions. However, this time, they're just rearranged. But when we multiply them together, they're equal to the exact same thing. So if that's the case, and we're dealing with all the same values, but this time they're just slightly more rearranged. 5 out of 6, 1 out of 6, 5 out of 6, we end up with the same fraction over and over and over again, which makes our math a lot easier. A lot of students think that this is going to be a lot of work. I'm just listing it out so that way we can see it, but eventually you'll be able to just see it in your head and solve for this. Right? So we have all of these different things, and then we need to go ahead and start adding these things together. We need to add together all the branches. So we're going to take branch 1 plus branch 2 plus branch 3 plus branch 4. Okay. So in this case, we're going to take the 125 out of 1,296, and we're going to add that together every single time. Now, if you're wondering, oh my gosh, Hernandez, this is going to be such a big number. Well, keep in mind, when we add together all of these fractions, you actually maintain the denominator. So what we're going to do is we're going to keep the common denominator, 1,296, and then we have 4 different values for 125. So this is like a different way to do some math. So in this case, we're going to do 4 times 125, which is 500, over 1,296. So she has a 500 out of 1,296 chance of becoming a defense attorney. So here, I'm going to zoom out for you all so you can take a look at some of these problems. Let me see if I can get all these. I can't get them in one page. But that's how you run through this problem. Take the opportunity to use this as a little bit of notes for you if you need it. And I'll catch you in class, and we'll have a good time. See you next time.